Hello and greetings from Berkshire Guitar Amplifier Repairs. Another video for you today, and on the bench we have a Marshall Silver Jubilee 50 watt. Don't think I've worked on one of these before, so this will be an interesting one. The problem that the customer has is also quite interesting. He said it was working perfectly okay, and then he put an effects pedal in on the effects send and return. It sounded absolutely awful, apparently, distorted and just horrendous. So we thought, well, okay, I'll take that out. Took the effects pedals off, and since then the amp has been low volume, badly distorted. I haven't looked in the amp yet, and from that description I don't really have a theory at the moment about what might be wrong with the amp. Anyway, let's turn it on and see if we agree with what it sounds like. Okay, the amp is on. Inputs kind of medium. Tone about medium. Standby's on. We've got high output. I guess this has some sort of switched bias on the output valves. As I say, I'm not familiar with this amp. Let's see what it sounds like. Oh, crikey. Well, there's no volume there at all worth speaking about, and it's highly distorted. Rightio, well, let's take the chassis out, nothing else we can do. Okay, thank you Marshall, that chassis came out like a dream, always a relief. And let's just have a quick look inside this. We're not looking for anything particular at the moment, just giving you a little tour, and to me, a little tour around here. Looks quite a nice amp, PCB mounting, components, and cable wired valves. Nothing obviously wrong here. I will just turn the camera off and have a close look to see if I can see anything obvious. Right, had a look around with the eyeglass, nothing immediately obvious. So the first thing I would always do is to check the HT. We know the HT fuse is okay because we had some kind of volume out of the amp. So let's have a little look around here on these caps. In fact, we can just go to ground with this probe and start probing around. 450 volts there, that's perfectly okay. 450 there, 382 there, that's good. Seems to be another one over here. A lot of HT caps here. 338 and 317, these will be doing the preamp side of things. So we have HT, okay. In a moment I'll put a bias probe on there to see what current we've got going through. But let's just have a little look around the bases of these EL34s to see if there's anything that we can immediately see. So here's pin 1, and we go around anti-clockwise. So 3 should be HT. It is for 450 volts. 1, 2, 3 HT, 450 volts. Yep. This is probably a screen resistor. Anyway, 3, 1, 2, 3, 4, 5 should be. I thought 5 was. Oh yes, I was going to say 5 should be negative bias, which it is. We've got, look, minus 42 on there, and on this one, 1, 2, 3, 4, 5. Is it that one? Yeah, minus 42. So we've got negative bias. I'm not quite sure how. Let's not worry about that for the moment. What else? Let me remind myself where the screen is on the EL34. I've just forgotten. I have a little kind of cheat book here. I can just look up all kinds of neat stuff. Right, so the control grid was on 5, which is what we said, and the screen is 4. So let's see what is on pin 4. 1, 2, 3, 4. This is the screen resistor here. Yep. 450, that's okay. And 1, 2, 3, 4. 450, so it looks like the screen resistors are okay. Nothing obvious. Right. Okay, well I think we're going to have to turn it upside down and get a bias meter on it and just see what those output valves are doing, whether they're drawing any kind of sensible current. So let's do that as our next thing. Before I do the bias meter, I'm just going to check the preamp valves. I always do the quickest and easiest things first. It's unlikely to be a preamp valve, but who knows? So let's pull V1. I'm just going to go along with a test valve here. A known good valve, shall we say. No change there. This is a very easy and quick way to fault find an amp. It only takes minutes, so it just makes so much sense to do it. Let's try V2. No improvement. I hope this isn't going to turn out to be something horrible like the output transformer. I don't know what on earth he could have done to it with that effects loop. I can't imagine what would cause that. Shouldn't have any trouble putting something through the effects loop. No, that was the phase splitter, and no improvement. That was worth doing. You know, it took a minute, so well worth doing. Right, let's get a couple of bias meters on these output valves and see if we can work out if they have any current going through them. Okay, got a couple of bias meters set up on 2 valves just so I can see what's going on. And what is going on is perfectly okay. We have decent HT, we have decent current, quite well matched set of valves. But we have almost no signal. Right. Okay, what I think I'm now going to do is to put a signal through the effects return here and see if we get a distorted signal coming through. The effects return is obviously a bit later down the chain, and that would eliminate some of the preamp stuff. So let's go in there with a sine wave from my... It's a bit hummy, I don't really know why. I'm maybe not overly worried about that at the moment. That's interesting. Well, I've got quite a large signal going in there from my... and I can only just hear it. That's a huge signal going in, and I can only just hear that. So that means that there's something wrong on the preamp side of things, I think. Okay. Right. I think I will flip it upside down again. We might have to get technical with this amp and actually break out the oscilloscope. I had someone email me recently saying, "Don't you ever use an oscilloscope?" And I replied to him, only if I absolutely have to, because most amp problems can be fixed without getting too technical with the amp. But I might have to put a sine wave in here and scope through and see what's happening on these 3 valves here. Something's gone wrong. It's not the valves, not the HT, it's not the power valves. Well, the next most easiest thing to do is just have a look at some voltages around on the preamp tubes. So let's have a look at pins 1 and 6, which are the plates of the ECC83. There's pin 1. Ha! Okay, I'm liking that. Hang on, was the amp on? No, the amp's not on. There we go. Might get a little bit more voltage there. Right, let's try again. So pin 1. We've got 240 volts, sort of what I'd expect. 1, 2, 3, 4, 5, 6. 200 volts, kind of what I'd expect. What have we got over here? A couple of hundred volts, that's okay. 2, 3, 4, 6. 100 volts on there. Bit on the low side, that. How about the phase splitter? 1, 250 volts, 2, 3, 4, 5, 6. 250 volts. Now why has V2 only got 100 volts on pin 6? 1, 2, 3, 4, 5, 6. Okay, a little bit on the low side, that. May or may not indicate something. Right. Well, unfortunately we're going to have to get technical with this amplifier and even drag the old oscilloscope out. So I've got a tone going through, you can probably hear that in the background, a lowish frequency. And I'm just going to measure onto pin 1 of the first valve. So that's there. Obviously there's a bit of hum there because I'm touching the very first stage, and as you can see we've got a sensible size signal there, a couple of volts peak to peak. Okay, so the next thing is to go on to the next stage. This is V1 of course, and go on to pin 6, which is the next stage. Pin 6 is this one here. Get on here and also show you the scope. There you go, we've got quite a decent signal there, several volts peak to peak. Okay, let's now try V2, pin 1, which is down here. And as you can see we have a whopping great big signal there. We've got about 20 millivolts going in at the input jack. So this is all working okay. V1 and V2A are working okay. However, when I go, I've done this already of course you might guess, when I go onto V2B, in other words pin 6, we have an extremely low signal. Just about to see it there. If I turn up the volts per division, so let's make that 1 volt per division, go back on there, you can see that our signal has kind of gone down greatly in value. So there's something wrong there. Now follow me through on this. Let me just turn that noise off. Right, so okay, so here's the schematic, and here's V2A, so we have a decent signal here coming through. Now this is interesting because if you remember we jacked into the effects return jack here and we still didn't get a decent signal. So the effects return jack comes in here, here's V2B, and here's where we're not getting a very high signal level. Normally, with nothing connected to this effects loop, this is connected to there. That connection is good. I've actually put a jack to jack lead in there just to double check there's nothing funny going on with dirty contacts on these jacks. You can definitely get that as a problem. So we have a signal here, and we don't have much of a signal here. So I guess the next thing to do is to, let me see, what's this, 100k and 10k, that's very interesting. This signal is actually padded down here by 10 to 1. I wonder why they do that. Go to all the trouble of amplifying it up here to get a huge signal here, and then pad it down 10 to 1 to send it off to here. That is very strange. I can't imagine why they would do that. So I think I want to try to get on here. I'd like to see what signal is on that 1 meg resistor there. So let me see if I can find that. Okay, I've managed to put the scope onto this point here. In other words, the link between there, and there it is quite clearly actually on the output jacks. Look, that jack is actually connected to there, so I've got the scope on there. Same signal going in, and we've got a fairly decentish signal there. That's kind of what I'd expect to see. About 1.5 volts peak to peak. Again, I don't know why they've padded that down from 15 volts peak to peak, but there you go. Now, however, okay, so let's go back to our schematic again, and you can see this now comes into this valve here, V2B, and I would expect some amplification there to get a larger signal here. So let's go on to pin 6. Well, it's interesting actually that it doesn't actually say pin 6 there. I suppose it's possible that these are swapped around, but yeah, maybe I ought to check that. Anyway, let's go on to pin 6. And you can see, if anything, it's a smaller signal than is going in. But let me just check that I haven't used, it would obviously be very logical to have pin 1 here and pin 6 there. But let me just check the components here to make sure I'm not fooling myself. Okay, I've confirmed that that is actually the correct thing. Pin 1 goes via this blue wire and goes to C24 and R35. So I've marked it up on the diagram now. 1 goes to C24 and R35, that's correct. And pin 6 should go to C27 and R38. That's this blue wire here. And that goes to, 6 goes to here, and that goes to C26 and R38, so that's good. So this is correct, and we should have a higher signal on here. So there's something funny going on around here. Well, there's not much in there, and if you remember, we've got a low, what I would consider to be a low voltage there, 100 volts. Well, that's 220k, that resistor, which is very large. So maybe they do want 100 volts there, not sure. Anyway, let's see, let's do some measurements and see what we've got. Well, I suppose we could check to see what signal we've got on R35, I think that is. That 1 meg. Let me see if I can find that resistor. We know we've got the signal here. Let's just check whether we've got it at the other side of that capacitor, in other words on the grid of the V2B. Okay, a little bit of a mystery here. Might have made some progress. So on this effects return jack here, here is the signal that we're after. Aha! That's interesting. Did you hear that break through there? So there's a decent signal, but look what happens when I go on the other side of the effects return jack, which should be shorted together. Very loud hum and no signal. Huge hum coming out of there. That should be shorted to there, from there to there by the switch of the jack, and it isn't. So did we hear that breakthrough when I moved this? Let's have a listen. I'm just waggling here now. There you go. Hear that? We have found the problem. It's this effects return jack. It's faulty, which is strange because I actually jacked that in. But anyway, there might be some other problem here. So I'm just going to turn the camera off and get the eyeglass on there and have a little look at those solder joints. And if they look good, we're going to probably have to replace that effects return jack. Now this is making a bit of sense now, because there's no reason on earth that him plugging some effects into his effects return send and return, would cause the amp to fail. There's nothing I can think of that would do that. So he plugs an effects pedal in there, it sounds awful, he unplugs it, and the amp's completely ruined, you know, low volume, no distortion, there's something weird going on there. So I reckon this was probably faulty anyway, the effects return jack. He'd never used it before, he plugs it in and disturbs the connection. So it might just be a solder joint on here. Let me get the eyeglass out and have a little look, and I'll report back to you. Okay, we've got a definite diagnosis here. You may not be able to see, but I can just get my screwdriver in and lift up the contact which is supposed to be contacting there, look. And when I do so, everything comes back to life. So that jack socket switch is not making there, so we need to replace that jack socket, and that will be a fix. Hooray! Took a bit longer than I expected, this amp. Right, I'll go and see if I've got a jack socket that will fit in there. Okay, it's about half an hour since we last spoke, and it's been really bugging me about why. I mean, we know we've got a problem with this effects return jack. We could quite clearly see the switch isn't working. But why didn't we get a signal when we plug straight into the effects return? That should have bypassed that and gone straight off to the amp. Also, the old trick about checking for dirty contacts is just literally to put a jack to jack lead from there to there, completely bypasses this lot, and if it's dirty contacts or whatever, it'll all spring to life. I did that because it's a known problem to have effects return jacks when you've got low level sound. That didn't do anything either. So what do you reckon about this? I'm having a little look here. Don't you reckon, look, this jack socket here, the switch is on the other side, you can't see it, all you can see there is a bent piece of metal. This jack socket here affects send. The switch, you may not be able to see, for which I apologise, is on the other side. It's not on that side, it's on this side. Here's our faulty jack, the switch is on this side. You can just about see it there. In fact, you saw me just lift that contact there. Here's the next jack, the switch is on the other side. Here's the next jack, the switch is on the other side. Here's the next jack, the switch is on the other side. I think someone's been in here and changed this jack socket. It doesn't look brilliantly soldered. I can't, it's not bad, but I can't really imagine Marshall doing that. I think someone's been in here. They've changed that jack socket, and they've changed it for an incorrect one. It's got the switch on this side. So this socket is incorrectly switched, which is why jacking in didn't do what we expected it to do. So unfortunately now I'm going to have to do a bit of signal tracing to work out where this screened cable goes. It obviously comes here, and make sure that I get the right connections coming back to here and work out how to connect this jack properly. So it's a slightly longer job than I thought, but I hope you agree with me about what's happened here, and it was seriously bugging me that jacking into here did not give us a signal. That's the reason. Okay, I've traced the wiring from this screened lead here to these two connections here, and this is all correctly wired. In other words, the blue should go to there, the red should go to there, the screen should go to there, but the problem is the jack is the wrong sort. It's got the switch on the wrong side. So if I take that jack out, put another jack in, here's one I got from stock, and as you can see immediately, look, the switch is on the right hand side there, just like all these other jacks, not on the left side. So if I just literally put that socket in there with exactly that wiring, I'm hoping that that will work. Well, let's do it. Okay, let's have a go at repairing this. I thought I'd show you this live. A lot of people like to see the detailed repairs. So we've got, I've made a little note of where everything is going. Just done a little quick sketch there of where all the connections go. So I think we can start just by chopping out this tinned copper link. I'll replace that. Take off this screen. Take off the blue. Take off the red. There we go. And what else have we got here? We've got a resistor from here to here. Looks like 1 ohm. Why have they put a 1 ohm resistor from ground to ground? Very strange. Can't imagine why they've done that. Okay, well, we'll chop off this piece of tinned copper wire too, probably replace that, and I'll chop off this 1 ohm resistor, and I think we can replace that too. Aha, that's interesting. So we have there's another problem here also, in that this earth wire going through here is not soldered. That's just that's just loose in its hole there. So that would definitely have caused a problem too. Interesting. Right, well, I think we're in a position to take this out now. There we go. And you can see, look, that the switch is on this side. There. That's sorry to keep interrupting and showing you new things, but this switch here on the ground side is sprung. Can you see that I can actually press that in there like that? It's not actually making that contact, and we know that this one was no good as well. So where this is someone's put this socket in, this is a gash socket someone's plugged in, and it was not working probably when it was put in. Anyway, look, switch on the left contrasts with the one I'm going to put in, where the switch is on the right. There you go. Right, to make my life easier, I'm going to just put a bit of tinned copper wire through these ground leads just to start with, and right, got a bit of tinned copper wire. I want to leave some extra on the left hand side here. I was just checking that to go to that next jack socket, so I'm just literally going to do this. This is where our 1 ohm resistor will end up going. So that socket that was in there was a right disaster, almost certainly been put in by somebody. I've texted the customer to see if he knows anything about it. Right, there we go, that's ready. I think we can probably put that in now. Go. Okay, so this we know goes across to here. Solder that one. Trim off the excess. So that's that connection done. We have this link needs to go from here to here. So I'm just going to completely remake that. So, old asbestos fingers come in handy sometimes. Run that through there, and then we'll make that a bit nicer in a moment. Meanwhile, we'll just run it around here. There we go. Shoulder that and reflow this. Good. That's good. Now all we need to do is to replace our... oh no, we've got that 1 ohm resistor. Let's do that now. Just want to check that is 1 ohm. I'm pretty sure it is. Looks like it from the colour code. Reading short circuit on my meter, of course, which it would. Oh, it's 10 ohms. Okay, it's a 10 ohm. Yes, of course it is. Brown, black, black. Silly me. That's a 10 ohm there. So no idea why they've got 10 ohm between grounds. Someone can put the answer in the comments. So there's a new 10 ohm resistor. I'll just check it on the meter. Off screen. 10 ohms, good, yep. So that needs to go from here to here. Just going to zoom out a bit on this one. Can't think of a good reason to put a 10 ohm in there rather than carrying the ground across. Might be some sort of earthing thing. No, don't know, no idea. I know nothing. So I'm just going to tack that in there. I'll bend this up here to make it a little bit more mechanically secure. I'll reflow that in a minute. For now, I'm just going to wrap this around here. The brain surgeons have got nothing on us, I tell you. The asbestos fingers didn't work that time. Right, good. Trim off the excess there. That's good. I just need to reflow this right hand side, if you remember. There, good. Okay, so we're good apart from attaching our little lead here. I'm just looking at my crib sheet here, and red goes to the left here, blue to the right. So let's do that. Blue onto there. And red onto here. Solved there. I'll pull that out in a moment. Throw red onto here. Good. And now the screen just goes onto the ground here. And then we can see if it works, which it should do. Because it never has. This has never worked properly since whoever put that jack in. Put that jack in. There we go. I make that job done. Let's turn on the amp and see if we've got a bit more sense out of it now. Oop, sounding good. There we go. That's working fine. And also should now be able to jack into the effects return. Won't be very loud, of course. There we go, that's working fine too. Hooray! Nice little fix that, and surprisingly, well, it was tricky because of course the amp wasn't stock. Someone with limited knowledge has been messing with it, which is never a good thing. We'll just put a couple of cable ties in here to tidy this up a little bit. There we go. That's it, job done. Well, okay, we got there in the end on this one. It definitely fooled me having that jack socket being replaced by one which was the incorrect switch side. Really had me going, that. It's a good old trick, that, plugging into the effects return to check whether the power section is working or whether it's the preamp section which is causing a problem. And low volume on an amplifier with an FX send and return jack is quite often dirt on the contacts of those jacks. Hence I jacked it out as one of the first things I did. But of course I wasn't prepared for an incorrect switch in there. Well, we got there, and I'm sure the customer will be very happy with this. I did speak to him and he doesn't remember that socket being changed, although he does remember it going to some technician a few years back who he wasn't very impressed with. So maybe, well, no maybe about it, that technician almost certainly replaced that socket for reasons unknown. Okay, well there you go, another one under the belt. I'm off to do my next one, and I'll catch you on the next video. Thanks for watching.